This says, find the probability that a random point will be chosen in the gray area. So for 20, I'm looking for the gray area over the whole thing. How do I find the area of the gray or the shaded? I have to do the area of the rectangle minus the area of two circles. Right? Area of the whole thing, which in this case is the rectangle. So the rectangle would be 3 times 4, which is 12. So 12 minus, and that's going to go over 12. And then the circles, if this whole thing is 4, then this is 2, and this is 2, making my radius 1. So that would be 1 pi plus 1 pi, or 2 pi. And then each of these are divisible by 2, so I would get 6 minus pi, so minus, over 2. So you'll keep it in terms of pi. That's 6 minus pi over 2. Nope, over 6. Questions on that one? Okay, 21. 6 minus pi over 6. Leah. 21, this time the area of the shaded region was just a small circle over the area of the big circle. So if this is 4, then this is 4, making the radius of that small circle what? 2. So the area of this small circle is 2, or pi 2 squared, which is 4 pi, over the area of the big circle, which if the radius is 4, it was 4 squared times pi, or 16 pi. Both the pi in the top and the bottom cancel out, and 4 goes into 16 4 times, so this is 1/4. Questions on that one? Okay, and then 22. Now I've got the area of that just little like donut shape on the inside. So I've got to do the area. I'm gonna color code this. The area of this circle minus the area of this circle. And that's going to be what I'm reaching for. Everybody see that one? Yeah? And then over the area of the whole thing. Okay? So area of this inner circle, not the like very, very small one in the middle, but the red one. If this is 2 and this is 1, this radius is what? 3. So it'd be 9 pi. Minus the small inside black circle in this one, which would be 1 pi, or pi, over the area of the whole object, which is going to be, this is 3, plus this is 2, making the radius 5, 25 pi. So I get 8 pi over 25 pi, and the pi's cancel, and I just get 8 over 25. So you've got to be really good at reading these diagrams and knowing what's what. Got to be careful. Yep.
How many questions are there?
On the test? 18?
Oh,
Yeah. Yep.
Are we going to get our quiz back?
Yeah. Didn't I give them back? Oh, you weren't here.
I wasn't here.
Yeah. Any other questions on the homework review? So the good news, 2 out of 9. So questions on any of those? Okay, 12-2. So permutation, where n is 7 and r is 6, is 5,040. 7, where n is 6 and r is 2, would be 30. 8, where n is 8 and r is 5, 6,720. And 1310 would be 1,037,836,800. Music, you downloaded 6 songs. You randomly choose 4 of these songs to play. Find the probability that you'll play the first 4 songs you downloaded in the order in which you downloaded them. So you got to figure out the bottom, right? 6 songs, how many would be the choice there? And then you randomly choose 4 songs. So the first one, you've got all of the options. The next one would only be 5 of the options. The next one would only be 4 of the options. And the next one would only be 3. Yep. So the bottom, right? We said we need to figure out the sample set. There's 6 songs, which means the bottom would be, 6 factorial, right? And then what's the probability that you play the first 4 songs you downloaded in the order in which you downloaded them? So for the first song, how many options are there for the first song? There's 5. Well, the very first song. There'd be 6, right? And then the next one. And then the next one. And then the next one. 6, 4, 3. So 6 times 5 times 4 times 3 times 2. Oh, wait, that's not right. That would cancel, that would cancel. No. This is in the order that you downloaded them. Sorry. So what's the order? What would be the probability of getting the first one? You need the 4 to be in the order that you have them in, right? Which means that there's only 2 possibilities left, right? So you're eliminating the 4. You get that? So it's 2. So this would be 2 and then 1, and this would be 6 and 5 and 4 and 3 and 2 and 1. 1, right? That's 30. 120, yeah, 360. You're welcome. Alexis.
How do you know it's going to be 1 over? Because I just did 6 permutation 4 and just got 360. Yeah, that's what I did.
That's your sample set, though. That's the bottom. That's not the probability of it. Does that make sense? That's how many different options there can be, right? So you could look at it that way, too. That could give you the amount of options that it would be, but there's only one set in which they are going to go in order, 1, 2, 3, 4. So that same process works, except you'd have to do that in the bottom. So your permutation of 6, 4, you said, right? Yeah. And then there's only one combination in which the first is going to be the first, the second is going to be the second, the third is going to be the third, and the fourth is going to be the fourth. Does that make sense? Yeah.
So couldn't you just do the permutation and then put 1 over it?
In this case, yes, because there's only going to be one in which the 4 are in a row. Yeah. Yeah, that's why I said you could do it either way. You could do it this way or you could do it this way. All right, 3. Now we're in combinations. 12, 3. So 11 is 7, 12 is 15, 13 is 56, 14 is 286. Which one didn't you get? 14. So did you do 13 factorial over 13 minus 10 factorial times 10 factorial? So 13, 10. Say again. No, so you'd have 13, 12, 11 times 10 factorial, and then the 10 factorials would cancel, but this is still 3 times 2 times 1. So you can, obviously the 1s can get canceled. 2 can go into 12 6 times, 3 goes into 6 2 times. So I'd have to do 13 times 11 times 2, or 13 times 2 times 11, 126. Yeah, if you don't have a calculator, Lord help you. I'm not really sure what you're going to do. So if you don't have it in your bag right now, set an alarm for yourself for tomorrow evening and put it in. Okay? You do not want to come to this test without a calculator. It will not be fun. And, I mean, it's possible, but it won't be enjoyable. Tomorrow, I'm going to leave you the extra review. Remember, I'm not here tomorrow. That's why we started the review a day early. Alexis. Oh, yeah, I didn't even get to it. So you win 5 tickets to a concert, and how many ways can you choose 4 friends out of a group of 9 to take with you? So there are 4 friends out of a group of 9. That's what you're looking for. So your combination with 9 and 4. Right? That should give you, I didn't work it out, but 9, this would be 5, and then 4, 9 times 8, times 7, times 6, times 5, over 5, 4 times 3, times 2, times 1. 3, gone, 2, 72, right? No, 63 times 2. Yeah, 126. So the 5 tickets is kind of what throws you off there. It doesn't matter that there's 5 tickets because you're taking one of them. So there are 4 other open seats. And remember, it's not like an assigned seating, so it's not like how many ways you can rearrange your friends in those seats. That would change it to a what? Good, permutation. Okay, 12.4, disjoint and overlapping. Remember disjoint, it's not possible for it to be both A and B, and overlapping is where it can be. So here's a lot of like and or the A bar, B bar. So if A is 0.32 and B is 0.48 and P of A and B is 0.12, find the indicated probability. So if it was an and, we would do what with those two? And you're going to multiply or you're going to add. So for the A or B, I just simply take the 0.32 and add it to the 0.48. A bar is what? What does that represent? The complement. So I do 1 minus A. And then for 18, I do 1 minus B. Lourdes.
How did 16 get 0.68 to add in? Did you subtract it?
16. Because there's an over, this is disjoint? Yeah, there is a possibility of it being both, right? So you have to do A plus B minus A and B. Does that make sense? Yeah, okay. Okay, 12.5. Now you're dealing with independent. So find the probability of randomly selecting the given marbles from a bag of 5 red, 8 green, and 3 blue marbles. If A, you replace, and B, you do not. So replacement is what? Independent or dependent? If you replace the marble. Independent. If you don't replace it, then it's dependent, right? The first one's going to affect the second one. So a red, then a green. If you replace it, is 5 over 32 because it would be red. Break that down. So the red would be 5 out of what? This is 13, 16, right? 5 out of 16. And then a green. If you replace it, how many greens are there? How many greens? 8, and it was replaced, so it's 8 out of 16, right? So a red and then a green.
Why is it 32?
Because it's not simplified yet, right?
But they both have 5.
What do you mean they both have 5?
Like for A, for the answer, they put 5 over 32, but you put 5 over 16.
I'm not done.
Oh.
This is an and, right? So you have to multiply? Yeah? So this goes once and this goes twice. And then without replacement, now how does that change it? The denominator on the second one, right? It's still 5 out of 16 the first time, but then it's 8 out of 15. So this goes this. And then same thing for red, then blue. So the blue, I would figure out what it is. With replacement, it's the blue was 3 out of the 16, and then the red would have been 5 out of the 16. Multiply them. And then without replacement, it would be the same start, so it'd still be 3 out of 16, but then the red would be 5 out of 15. And then green, not only does the first one, so the green would be 8 out of 16 times, what changes this time? If you do not replace it, so this is for B, it's 7 out of 15. Good, both of them change, right? Because it's the same color. Questions overall on any of that stuff before I go back to the 11.4? Alexis.
The number 18, the P, B was 11, what's that equation?
That's 1 minus the probability of B. So that little bar means the complement, and the complement is 1 minus the probability of whatever that letter is. They gave it to you in this case, right? They said probability of B is here.
Will they give it to us on a test?
Part of it, yeah. Part of them you got to figure out, but part of them they give it to you, yeah.
So for 12.4 and 12.5, will it be like on the test?
There's going to be other things like it,
But it's going to be like,
but there will also be parts like that where they give you the probability of A and B. And then there's going to be ones where, like the red card and the diamond, where you got to figure out that that's an overlap, right? Yeah. Camilla.
what's the equation for 16 and 17?
What's the equation? So the OR is the probability of A plus the probability of B. And if there's an overlap, minus the probability of A and B. And that you know because of this, like it says that there's a probability that A and B overlap. If A and B didn't overlap, the probability of A and B would be 0. Alexis.
Wait, is the probability of A over B is literally A over B? Like,
Wait, A over B. Say A over B. What?
Or the A over B, you have the probability of A plus probability of B minus the probability of A.
Given B. Oh, the little dash.
Yeah.
That's right, as the probability of A occurring given that B has occurred. Other way, that should be the other way around, sorry. The probability of B and A.
How do you find that?
That's here. That's the probability of A and B happening is 0.12.
Well,
That's if they give it to you that way. If not, then you have to think about like that you're overlapping. So these were the examples there were like a 10 and a red card, right? Overlapping means they can exist. Can you have a 10 red card? Yeah, right? So you'd have to do the probability that you get a 10 plus the probability that you get a red card minus the probability that you get a 10 red card.
oh, okay.
That's what this whole little section is. That's the disjoint and overlapping. Any other questions on 12? Again, before I go back to 11.4. Okay, 11.4. Or extra example. Guys, the coach for the swimming team randomly chooses 2 of the 12 members of the team to talk to local reporters about an upcoming meet. What's the probability that the coach chooses you and your twin brother? So this is 1 out of 132 is what it is. Okay? And I'll tell you, I think that my brain, instead of trying to figure out permutations and combinations here, makes it easier as a probability of A and a probability of B. Like, I think that that's easier to look at. So what's the probability of you getting picked, and what's the probability of your twin brother getting picked? And the word and means you're going to do what with those probabilities? Multiply them. So if you're the first to get picked, you would be 1 out of how many people? 12. If you're picked, and now they want to, what's the probability that your twin is picked? Assuming that you have been picked, right? How many people are left? 11. So this would be 1 out of 11. And that's 1 of 132. Did anybody do it with the permutations or combinations to get it right? So how'd you set yours up? Because there's different ways to do it.
I did 10 factorial or 12 factorial because we took 2 of the people out.
2 of the people are gone, and out of the 12 total people, that works too. So there's a lot of different ways to look at it. You got to figure out what makes it easiest for you. Instead of trying to figure out combinations, permutations, sometimes it's easier to do that way. All right, your dog has 6 puppies. You can choose 2 of the 6 to keep, and we're not euthanizing. We've already established that. How many choices of the 2 puppies are there possible? It doesn't matter. You're not filling a first spot and a second spot, right? You're just keeping 2. So this is a what? This is a combination. It would be 6, 2, and from that you get 15. Okay, extra example 4 says let A and B be events such that probability of A is 4/5, probability of B is 3/10, and probability of A and B is 3 out of 25. Find A or B. So we're assuming that there's an overlap. That's thus the A and B. So I would do the probability of A, which is 4/5, plus the probability 15. Probability of B, which is 3/10, minus the probability of them both, which is 3 over 25. And then we have to rely on our least common denominator skills, right? I would change them all to be 50, so this would be 50 times 10 here would be 40. This would be 50 times 5 here would be 15. This would be 50 times 2 would be 6. And then 40 plus 15 is 55, minus 6 is 49 out of 50. God bless you. Find the probability of selecting 9 and then another 9 from a standard deck of 52 cards if you A, replace, and then B, you don't. So A is replacement, meaning how many 9s are there in the deck? 4, so this would be 4 out of 52. And it says and, which means what? Multiply. So I could already reduce this, right? This would be 1 out of 13. And then if I've put it back, which it says the first one, you replace it, how many 9s are there? 4, and there's still 52 cards. So this would be 1/13 out of 1/13, or 1 out of 169. And then you don't replace it. I'd start the same way, 4 out of 52, or 1/13. But then what changes the next time around? Denominator this time, and the numerator, right? It's the same one you want back. So the 9s, there's only now 3 of them, and there'd only be 51 cards. Cheat, 13 times 51. 663, which is 1 over 221. Questions? Everybody okay? Yep. All right, so again, tomorrow you'll spend the class time doing the extra review, and then I will post the answers to it tomorrow evening. Test is Wednesday.